Here's the graph of the cotangent function. We can get the cotangent function by putting the first coordinate from the unit circle over the second coordinate. The first coordinate's the cosine, the second coordinate's the sine. So the cotangent is equivalent to cosine x over sine x. That's a fraction, so it's going to do some fraction things. Any fraction is equal to 0 where its numerator is 0. So the cotangent is going to have a 0, have an x-intercept wherever the cosine is 0. And we know something about that. The cosine values are 0 at odd number multiples of pi over 2. Cosine of pi over 2 is 0, 3 pi over 2, 5 pi over 2, 7 pi over 2, the negative ones, any odd number multiple of pi over 2. And that happens. I just said where it happens. Odd number multiples of pi over 2. We can say that all at once. Let's see, here's pi over 2. I just have to make an odd number to multiply it by. If I start with any integer and multiply it by 2, now I have an even number. No matter what n was, 2 times n is even. To go from an even number to an odd number, I can just go up by 1. So there's odd number multiples of pi over 2 is where my cotangent function is going to have a 0 value. When the denominator is 0 and the numerator is not in a fraction, I'm going to get a vertical asymptote because my function is undefined. So my cotangent function is undefined when the denominator is 0. We know where sine x is 0. That happens at 0 and pi and 2 pi and 3 pi and 457 pi. Any whole number multiple of pi. And we can sum that up and say a whole number multiple of pi, n is an integer. Every whole number multiple of pi, my cotangent function is undefined, which means I'm going to have a vertical asymptote there. We got some information enough to start drawing a graph here. Let's see, I'm going to have vertical asymptotes at every whole number multiple of pi. So let's put pi, here's 2 pi. I go over this way and have negative pi. 0 is an asymptote. And halfway in between all of these, my function is 0. So I'm going to have zeros in the middle. That's not enough information to draw a graph, so I'm going to pick pi over 4. Cotangent of pi over 4, well, the tangent of pi over 4 is 1, so the cotangent of pi over 4 is the reciprocal of 1, which is still 1. I'm going to have a point right there. Here's 3 pi over 4. Tangent of 3 pi over 4 is negative 1, so cotangent of 3 pi over 4, also negative 1, like that. As I get closer and closer to my asymptotes, my function is going to veer off next to the asymptote like that. We don't cross vertical asymptotes ever. So my cotangent function looks something like that, and that's going to happen in between every pair of asymptotes, which notice what that means. That means the period of the cotangent function is pi. It's not 2 pi. It repeats itself every pi. Not every 2 pi like the sine and the cosine. We can say something about the domain. The domain, I can find the cotangent of any number except for where the asymptotes are. But good news, we know where the asymptotes are. So I'm going to say all real numbers except the places where the asymptotes are. The range Well, I can get any y value I want, top to bottom. So the range, all real numbers. And let's take a look at the nice Desmos version. There it is. Y equals cotangent x.